So this is a 6 marker and it's based on alkenes and nomenclature and isomerism. I recommend you pause, have a go, and when you're ready, move on and review your answer. So as always, it's down to having 3 different levels, 3 different stages. Have a read through to see how you get through to those levels. And we're going to look at stage 1 to begin. Now, stage 1 is simply about whether it is saturated or unsaturated. A and B are unsaturated because they do decolorize brown bromine water. C is saturated because it doesn't. Level 1, stage 1, done. We move on to stage 2 where we're identifying the compounds. Now, A is an alkene, but it doesn't show stereoisomerism. I have a 3-tick rule when I'm deciding whether something shows geometrical isomerism. Does it have a double bond? Tick. Yes, it does. Does the carbon on the left of the double bond have 2 different groups coming from it? No. Now, because I've not got that second tick, I can't have all 3 ticks, and therefore it does not show geometrical or stereoisomerism. When I move on to B, I'm looking at the fact that does it have a double bond? Yes. Does it have 2 different groups on the left-hand side? Well, it will do when I finish it. Does it have 2 different groups on the carbon on the right-hand side? Yes, it does, once I've finished drawing it. And you can see here that I've got a hydrogen and an ethyl on the left, a hydrogen and a methyl on the right. So each carbon has 2 different groups coming from it. That means it does show geometrical and therefore stereoisomerism. Identifying C, which is still C5H10 but doesn't show stereoisomerism, so we're looking here at functional group isomers of alkenes, more specifically cycloalkanes. Now, these are not necessarily the only answers that you can give, but these are the most straightforward and logical answers you could give. Moving on to stage 3, and that's explaining the stereoisomerism. And I've already touched on this when we were drawing out A and B. First of all, let's say what it is. Give the definition. Same structural formula, but a different spatial arrangement. There's no free rotation about the double bond, and then each carbon on the double bond has 2 different groups connected to it.